the next shape I'm going to take you through is a triangular prism. And at first you might think, oh, a triangular prism, it's pretty easy. There's actually quite a lot to think about with a triangular prism. So the first thing that you have to actually think about are your dimensions and also what your shape might look like. So there's two different ways that a triangular prism can look. It can look like what I call a Toblerone bar, where it would be your triangle going back. So if you picture a Toblerone bar, right, it would look something like that. That obviously wouldn't be a drinking vessel, but if you drew it this way, actually, I'm just going to put the line. So if you drew it like that, that would make a drinking vessel. So it would be more with the triangles top and bottom and then taller. When you have one like that, keep in mind with your dimensions, base in a triangular prism means base of the triangle. Height in a triangular prism means height of the triangle. So the height would actually be here, which is a little confusing. And then depth refers to how far apart the triangles are. So kind of, in this case, for many of you, depth is almost kind of like the height, if that makes sense. So depth is really how tall it is. It's just hard with the triangular prism because height refers to height of triangle. So if you had a shape like this that looked more like a Toblerone bar, your net is going to look more like 3 rectangles, and the rectangles will not necessarily be the same size. So I've drawn them as if kind of they're the same size, but they probably won't be. If you're doing a Toblerone bar, chances are you've got an isosceles triangle up here, because keep in mind this is your base, and then your height would be here, and then your depth would be this part here. So chances are you've got like an isosceles triangle. So that means that the these two rectangles that I just marked with an X are probably the same size. And then this rectangle in the middle is probably a different size. So that's something to keep in mind. Now, the interesting thing with a triangular prism that makes it more complicated is this particular length. So if you think about what pieces match up, this side here would match with this side here. Likewise, this side would match with this side. So if it was isosceles, so keep in mind that if your triangular prism, if these two sides of your triangle are equal, then these two sides of your rectangle must also be equal. You need to know how long that is before you can draw this and before you can do a surface area calculation. That is not the same as your height, and it's not the same as your base. What you're going to have to do is use Pythagorean theorem and find the slant height. Find the height of that slanted part. So picture this triangle right here. And here is your base, and here is your height. You're going to need to find this part, which is your slant. Now, it's not as simple as doing base squared plus height squared and then square rooting it, because the right-angled triangle, if you look at what I've drawn here, the right-angled triangle is only going to be half the base. The height is there, the slant is still there, but you only are using half the base. So you're going to need to do the base divided by 2 squared plus the height squared, and that will give you the slant squared, and then you'll square root that. So triangular prisms are actually quite difficult to think through. Now, I said this as if your triangular prism looked more like a Toblerone bar. You can also have a triangular prism that looks more like what I call it a block of cheese. It's probably not really a block of cheese, but if you picture like a Swiss cheese block, to me it kind of looks like that. So you're going to end up with a triangular prism that maybe has a right angle in it that looks something like this, where your base, again, is the base of the triangle. Your height, again, is the height of the triangle. And your depth is the distance between the two triangles. So that might be your drinking vessel. If this were your shape, so again, we might want to draw out here, and you could picture you've got your two rectangles and you've got two right-angled triangles. So your net might end up looking, actually I'm going to go back here just to make sure. All right, so you've got more of a thinner, I probably won't be able to draw this super accurately to how it looked, but you've got more of a thinner rectangle there and then longer rectangles over here. In all likelihood, your three rectangles here are going to be different sizes. Keep in mind, remember, this was the base. This was the height. Remember, the depth is how far apart the triangles are, so that's tricky to think about here. The depth is actually that distance right there. Now, again, in this case, you got to think about what matches up. So this side and this side match up, likewise there, okay? This side and this side match up, likewise there. So you've got to really think about when you're labeling what pieces match up. So if this is the height right here, that's the height, then this length is also going to be the height, right? Because they match up. What about the green highlighter? What would that be? Well, again, that's going to be slant height. In this case, your triangle looks like this. And here is your base, and here is your height, and here is your slant. In this case, it's a right-angled triangle already. So you don't do half the base. You just do base squared plus height squared equals slant squared. So compare that to what we did up here, where we had to do half the base. That was because this was more of like that Toblerone bar, and it had more of an isosceles triangle that we then had to find the right angle triangle. If yours is more like this, you already have a right angle triangle. So you would use just the base squared plus height squared equals. So before you can draw the net, before you can calculate the surface area, you need to think about, one, what does your shape look like? Does it look like this shape here? Or does it look like this shape here? Then you think about, what does your net look like? Would it look like this? Or would it look more like this with the right angle triangles? And then you can find your slant height. So triangular prisms are a bit complex.